Okay, in this next video, we are going to take these orbital diagrams from our homework document number 8, and we're going to take all these diagrams and we're going to transform them into this simplified electron configuration notation. So again, just to review, in electron configuration notation, you still list the energy level, the orbital shape, but instead of drawing the lines and all the arrows, we're going to count up the electrons that are in this orbital and place that number here as a superscript. So let's look at our first example. We have beryllium, which only has 4 electrons, and as we can see from the orbital diagram, we only have electrons in 2 orbitals. We have them in the 1s orbital and the 2s orbital. So I'm going to list that out, and I have to list them starting off first with the orbital in the lowest energy level. That would be the 1s. And in the 1s, from my picture here, I can see there are 2 electrons in that orbital. Next thing that I list is the next energy, the next orbital of energy, which is the 2s, and from my picture I can see, that I have 2 electrons in that orbital. So the electron configuration for beryllium is really just 1s2, 2s2. Over here for copper, this is going to get a little bit more complex because we have many orbitals over here. And just like when we went through and drew out this orbital diagram, we used some tools like our Aufbau diagram. We still have to use this for electron configuration. So between this diagram here and still applying this, we're going to write out copper's electron configuration. Again, according to Aufbau, we have to start at the lowest energy level and then work our way up. So I'm going to go in this manner of 1s, then 2s, then 2p, then 3s, and then 3p. So let's see here. I start off my configuration with the 1s, and there are 2 electrons there. Next, according to Aufbau, is the 2s, and there are 2 electrons there. After 2s comes 2p, which there are 6 electrons. After 2p is going to be the 3s, which there are 2 electrons. After 3s is 3p, and there are 6 electrons in that level. So I've done 1s2, 2s2, 2p6, 3s2, 3p6. I look at my orbital diagram. After 3p comes 4s, and then after the 4s is the 3d. So back to my diagram here. I've already written down this one, this one, this one, this one, and this one. But after 3p comes 4s, not 3d. So I'm going to write in 4s, 2, and then 3d. I look at my picture here. I have 2, 4, 6, 8, 9 electrons. So I write a 9. And that's how we translate our orbital diagrams into electron configuration. Over here for potassium, again, we start with the lowest energy level, 1s, and there are 2 electrons there. Then comes 2s, and there are 2 electrons. Then 2p, where there are 6. And then the 3s with 2, and then the 3p with 6. And then last, the 4s. But in this one, there's only 1 electron there. For niobium, we are going to, again, get into some of these d orbitals. So a little bit more complex than beryllium or potassium. So we're going to want to make sure that we have that Aufbau diagram handy so we can continue to make sure that as we write out this configuration, we're still staying in Aufbau's order. We know that we always start with 1s, so that's 2, 2s, 2, 2p, 6, and after that comes 3s, 2, then the 3p, 6. After 3p, you might be tempted to write 3d, but if we check the Aufbau diagram, after 3p comes 4s, not 3d. We have to fill the 4s before we come back to 3d. So after my 3p, I'm going to write down these 2 electrons found here in my 4s orbital. 4s2. After 4s, we come back down here to the 3d. From my picture, 3d I can see is filled. 3d, so that makes 10 electrons. 2, 4, 6, 8, 10. After 3d is going to come 4p according to Aufbau. You can check your diagram, but you'll see that after 3d comes 4p. And then after 4p will be the 5s. And then after 5s, from the Aufbau diagram, we're up here at 5s, we come back to this 4d level. So our final thing that we write down is 4d, and we count that up, 1, 2, 3. 4d3. So this is all it is for writing in those electron configurations, translating from orbital diagrams into electron configuration notation.